All right, we're looking at 5-3 today, and like I said, we're dealing with adding and subtracting decimals. Now, as I was prepping up for this lesson, I was thinking, I don't think they're going to have a problem with this for the most part. You know what I'm really worried about today's lesson? Is that you know how to do it so well that you're not careful and you mess up on little things. So just make sure that you're being careful, and we'll work on that today. So we're talking about adding and subtracting decimals. Now, what's the whole chapter about? Do you guys remember what the whole chapter is about? It's about a type of number, rationals, all right? And decimals are a type of rational number. Okay, so decimals are what we're talking about. I told this in the last class. As a math teacher, there are some things that, like, for years now, this is my, I always forget, is it 7th or 8th year teaching? But I always want to get better at this. Teaching my students how to deal with decimals and fractions easier or understand it better. Like, I really wish I could just come with the ultimate plan to just give it to you guys and you never struggle with it again. I haven't gotten there yet, unfortunately. But I think we took a step into the right direction last class period, and I hope it helps out this class period. Okay, we're talking about adding and subtracting decimals, and you know what? It's almost the same thing as adding and subtracting integers. So you remember we did that a couple chapters ago? We're going to do it now with these decimals. But before we do that, we need to review, or we need to take a review or have a review of properties. You guys remember properties? Properties, the blah property, this property, that property. So I'm going to list out some of them, and I'm not going to give the full definition. I'm going to give you like a key word or phrase. You want to go ahead, Josh?
Actually, we won't have anything this week. We'll probably have a test next week. And a
Tuesday, yes, I got to put that up.
Okay, and a test next week, and then for like
Possibly the end of that week or the following week.
And then
maybe like a quiz before you leave. Yeah, you won't have 2 more tests. You'll have 1 more test and 2 more quizzes before your break. And by the way, guys, you understand that your second quarter ends after Christmas break, right? I know, that's weird. It hasn't happened like that for a while. So normally at Christmas break, right when it starts, second quarter is done. But this year it's going to be Christmas break starts, and second quarter goes into Christmas break, and then just I think 2.5 weeks after it, you get your end of your second quarter. Okay, so we're not done with the grades at Christmas break. We still have a couple more weeks. Does that make sense? It's different.
Do it after Christmas break.
We'll do some more things after Christmas break that will be added to your second quarter. Yeah, the year just got pushed out further. All right, but it's weird because it goes through a big break. Do you guys remember commutative property? Okay, you may remember the word. Does anyone know how to describe the commutative property of addition? Parker?
Changing the order. Things doesn't change the sum.
Okay, good. And you get the key word I want you guys to get. It's order. When you switch the order of the addends in integers or rationals, like decimals and fractions, it does not change the sum. Commutative refers to order. Do you have to add in the same order as everyone else if you have a string of addition numbers or addends? No. So you can do it your own way. The second one I want you guys to get is the associative property. And does anyone remember the associative property? Sarah, back there?
grouping.
Oh, very nice. Grouping. That's the key word, grouping. So the grouping of the addends does not affect the sum. And let me give you a problem here of how you might want to use this. A very simple problem. So if I had 3 plus 8 plus 7, tell me what I'm going to do. Tell me which property I'm going to use to make this next step happen. So what property was just used from the first to the second? Cole? Commutative property. Now what property am I using? Davis? Associative. So commutative, the order changes. Associative, I group them in different ways than they were already grouped. In this case, they were not grouped, and then I decided to group these two. Why in the world would I group 3 and 7? Is it because they look really nice together? Why do I group them together? What's the benefit of that?
Because
they make 10?
Oh, yeah, isn't 10 plus 8 really easy? 18. Could you do it this way? Of course you can. I don't doubt that. But this is a lot easier to look at. And by the way, you don't actually have to always write those steps down. You can actually think of it like this. I look at this problem like 3 plus 7 is 10 plus 8 is 18. You use the properties without having to write each step. Okay, so that's one of the ways you can use it. Can you use that on decimals?
Yeah, maybe.
You can. All of these properties work with decimals and fractions, which we'll look at later. All right, the third one is identity. And does anyone remember the identity property? The identity property of addition. Parker's got them all here. Can someone, Matt, you want to try? Yes, and actually that's what I'm going to put here. Add 0. What happens when you add 0 to any number? What happens to that number? Stays the same. And you're like, well, duh. And why would I even want to use it? In algebra, we use this all the time. And so often that it's automatic. It's like add 0, add 0, add 0, add 0. I already know the answer to that. It's the identity property. And then the last one here, this one needs a little bit more explanation, but maybe some of you can get it. The inverse property of addition. And you can look on page 234 and see if you can kind of describe what is going on there with the inverse property. Not yet, but yes, later. Okay, what's the inverse property? Look at it. Let's try to see if you can explain it to me. It's tough. Okay, Nick?
So it says a plus negative a equals 0. So
What is that?
a
Yeah.
number plus itself equals, or plus the negative number of itself equals 0.
Okay, I'm going to say it this way. A number plus its, plus its opposite equals 0. Any number plus its opposite equals 0. All right, give me a decimal number. Somebody help me out with a decimal number. Sarah?
0.5.
All right, so I'll put 0.5. Okay, what's the opposite of 0.5? The opposite. Cole? Negative 0.5. And what happens when you add these two together? Automatically gets you 0. So any number plus its opposite will give me 0. Now, do you notice how inverse and identity both have 0 in them? But are they the same? No. One, you add 0 to a number and you keep its identity. And one, you add two numbers and they give you a sum of 0. That is not the same thing. Please keep those distinguished. All right, you guys good with those? It's just a review. Now, the whole point of this review is this. I like integers. Positive 5, negative 10, negative 1,000, positive 3. But when I start looking at decimals and fractions, something happens up here. I start looking at those numbers and I start getting confused. I need to realize that those numbers, rational numbers, are just like integers. I can apply the same properties, all of them. All the properties apply to them. Okay, let's actually get to the math portion here. Example 1a. We have 3 problems here. A starts with m equals 13.2 plus 11.7. What did we do yesterday? Very good. We estimated by rounding. So let's do that again. Now, I'm going to give you a heads up. Ready? Listen to me, because if you ask me this question, I already gave you the answer. On these problems on the board that I do with you today, I'm going to estimate and then work them out. I'm going to say you don't have to estimate. So if someone says, Mr. A, do we have to estimate them as well? What's my answer? No. I'm doing it to apply yesterday's lesson to today's lesson. So I'm going to do it every problem, and you should write it down. But on your actual homework, you do not have to do this. All right, I'm going to abbreviate estimation. What would you round these two numbers to estimate? Nick?
13 and 12.
13 plus 12 gives me what? 25. Okay, that's an estimate, so shouldn't my answer be approximately 25? Okay, not exactly necessarily, but approximately. All right, let's go ahead and actually add these together. And like I said, I don't doubt your guys' ability to add or subtract decimals, but what's the key rule for adding or subtracting decimals? You must do this. On every one of them, you must do this. Josh? Line up the decimals. So I'm looking at the actual numbers. 13.2 plus 11.7. Are my decimals lined up? Yes, they are. Phew. Then I can just add them up. Now, one of you asked me yesterday, Mr. A, can I switch these around? Can I put the 11.7 over the 13.2? And my answer was what?
Yes.
Really? You can do that? You can just switch them around? Why? Commutative property. So if you prefer to have that one on top and the other one, it doesn't matter. You can do that. That's for which operation, by the way? Addition. Okay. Everyone, 2 plus 7. Yes. 3 plus 1. 1 plus 1. Okay. This problem said solve that equation, and I get 24.9. Is that my answer?
No.
Really? I thought I did the math right. Sorry, Nick?
M
equals 24.9. That's what I want. So, again, do we have to write the estimate out? No. But I do it so that I can check my actual with the estimate. Now, let me ask. Is my estimate close to my actual and vice versa?
Yes.
Yes, they're very close. So it's reasonable. That means it makes sense. All right, with B. They give us G equals 231 minus 126.7. All right, again, I want to see what estimation helps me with. So what do you think you would round these two numbers? What place value would you round them to? What do you think, Scout?
I would do the first one 130.
Okay, sorry, this one? To 230?
Yeah, 230.
230, that's right, 230, and you're rounding it to the nearest 10. And then
Second one would be 130.
130. So you're rounding it to the tens. And what's 230 minus 130? 100. So shouldn't my answer be close to 100? Okay, now, did I have to pick the tens value when estimating? No, I could have picked the hundreds. I could have picked the ones, but why would I probably not want to pick the ones? What do you think is not so great about doing the ones for rounding both of these? Anyone know? Yes, ma'am? So it will work, like it'll give you a number.
Like, that's easier.
Yeah, this is easier. And if I round it to the nearest ones, that stays 231, that stays 120, or that becomes 127. I changed it slightly. I basically did the problem without doing the problem. So make it worthwhile, make it easy, and then you can actually do the actual problem and not take that much longer. All right, so here, 231 minus 126.7. Uh-oh, where's the decimal on 231? Yeah, it's at the end, so 0.0 for a place value holder. All right, 0 minus 7, can't do, so I borrow from the 1. 10 minus 7?
3.
0 minus 6, oh no, I can't do that, so I got to borrow again. 10 minus 6? 2 minus 2? 2 minus 1. Where's the decimal go?
Right in front of the 3.
Yeah, and we would say between the 4 and the 3. So that's my answer. Yes.
No.
What?
G.
Oh, yes. It's solving an equation. G equals 104.3. Is that pretty close to 100? Does my answer make sense? Probably, yes. All right. Oh, my. The toughest type of problem there is in this lesson. Oh, man. D equals 8.3 plus negative 12.5. Okay, maybe this isn't the hardest, but it's getting there. It's getting there. All right. I stare and I stare. I'm going to estimate because I really don't know what these mean. Maybe estimating will help me out. What is 8 point? What should you round these to? What would you think? Yeah, to the 1, so I get what for 8.3? 8 plus negative 13. And what's 8 plus negative 13? Negative 5. Okay, so that's my estimate. So my answer should be close to that. All right. Actual. I need you to be careful with this. You're adding opposite sign numbers. So how do you deal with it here? Well, which one has the higher absolute value? Which number is further away from 0? The positive or the negative? The negative 12.5, right? So what's my answer going to be? It's going to be negative. And then what do I do with those two numbers to find what number follows the negative sign? Because I don't know what to do. These are decimals. They scare me. So what do I do? You have two options. You add or subtract. So which one?
Well, you should make up.
Yeah, you subtract those numbers. Yeah, and I guess I should make that clear. What do you do with the 8.3 and the 12.5? You should subtract. Now, this is how you guys are going to do it, and you need to be careful here. Some people do this. 8.3 minus 12.5. Now, why are you not allowed to do it like this? You're not allowed to do it like this, and you shouldn't do it. It's going to get you a wrong answer. Why should you not do it this way? Someone see it? Yes, Murphy?
Because the 12.5 is supposed to be on the top.
Yes, the bigger number, when you're subtracting it this way, the bigger number has to be on the top, smaller on the bottom. Make sense? So I can't do it that way. So I have to do it what? How do I write this problem out? 12.5 minus 8.3. All right, what's 5 minus 3? 2 minus 8, can't do it. Yeah, borrow. 12 minus 8. All right, that's the answer, right? Negative 4.2 equals D. Yeah, it's solving an equation, so it equals D. Oh, wait, is negative 4.2 close to negative 5? Yes, it's not exactly there. It's 8/10 off in this case. That's okay. That happens. How many of you think you're good at this right here? You got it? Good. On page 235, I need you to do number 12. Find what C equals. Number 12 on page 236, number 12. Go ahead and do that one on your own. I will estimate it up here, and let's see how you do. Let's see how you do here. So I got my estimate on the board, and you should have your actual coming up soon. Now notice, what's my estimate's sign? So what do you think your actual sign should be? Okay. This is what a lot of people do on this problem, and it's understandable. I get it, because you're just subtracting. A lot of people do this. Is this correct?
No.
Why not? It's subtraction. The bigger number's on the bottom, so you need to switch them up. And what's the sign of your answer? Negative. So it's not this. It's 43.0 minus 34.2. All right, so who got an answer? I need an exactly correct answer. No pressure here. Betsy?
I got 9.2.
Close, very close. I think it's a borrowing thing that happened there. Rachel? Is that your final answer? Cole, you want to help me out? Yeah. Rachel, am I picky?
Yes.
Did you get that, Swivl? I'm picky. Okay, it's C equals negative 8.8. How many of you did it like this the first time? Like you knew I got to do it this way. You can't do it that way. Okay, please don't do it this way. Never, ever, ever in your life ever do it this way. Ever. Unless you want to get the wrong answer. Then you can do it. But yeah, this is the way you get the right answer. And it's going to be a negative. Now for the hardest problem. Sorry? Because you do a smaller number minus a bigger number. So you're taking away from it more than it has, it gets down into the negative, unfortunately. Well, I guess it's not unfortunate, that happens. Example 2. Here's the problem. 4.7x plus 6.3x minus 13.7x. Ugh. A lot of x's there. Wait. How many of you remember these are like terms? Does anyone remember what a like term is? How do you describe a like term? So, yeah, they're like terms. What do you mean by that?
It's when in algebra you have all of the same terms and variables.
Okay.
And combine them together.
How many terms do I have up here? Anybody? How many terms? I have this term, and this term. You guys agree with that? Are they like? Why are they like? Cole? They have the same variable. They all have x. So if you have like variables, you can combine them together by adding these numbers in front. And actually, you guys remember in science? Coefficients. This is a coefficient of x. This is a coefficient of x. And this is a coefficient of x. Add or subtract the coefficients of x. Okay, so do you remember order of operations? Where you go? From left to right, you do what? Add or subtract, whichever one comes first. I'm going to do these two first. So 4.7 plus 6.3. And now I got to add these up. And what do we get with that? Okay, just 11. And in this case, it's going to be 11x. So far, so good with that? Minus 13.7x. Second. Hold on. I know what you're thinking. So is this answer going to be positive or negative when you combine these? It's got to be negative. So you do this, right? 11 minus 13.7? No. 13.7 minus 11, and then it gets a negative sign. What's my final answer? Final answer. Chelsea? Are you sure about that, Chelsea? Oh, yeah, because it's going to be, and this is it. It's going to be 13.7 minus 11. So you get 7, 2. Gotcha. Oh, that's right. It happens. But negative 2.7x. How many of you sort of, kind of, maybe really understand it? Good. So you're going to do number 15. Oh, excuse me. On page 236, number 15. 15. That'll show me if you know it. And I'll write it up on the board, and then I'll get your input. Number 15. Just be careful with that negative or minus 8m. 8 is not a decimal number, so change it into that if you need to, but don't expect it to be that right away. Man, I'm looking at this problem. Isn't this lesson about addition and subtraction? What do you have up here? Subtraction or, anyone know? Whoa, Sarah, you're starting to. Are you telling me this is addition as well? Huh. If that totally went over your head, you're like, don't know what you meant there. That's okay. We're gonna get to that later. But go ahead and work it out the way you know. What do you do first in this problem? I don't know what to do. I'm scared. Sarah?
You do 5.3.
All right, 5.3. Oh, are you allowed to do that?
Yeah.
Okay, good. So we'll get 4, 1, 9, 3. 3.9 m. Okay. Minus 8m. All right, so how do I deal with that? Davis? Wait, Davis. Davis. You are 1 year older than you were the day before? Okay, pause. We do have to sing happy birthday to Davis, and I have two things. Well, I have two things for you, Davis, okay, and one for the class. We get to sing happy birthday to you. That's great. That's your one thing. And then for everybody, I'm going to give you something else in just a couple. Whoa. Don't get too excited there. And it's nothing. It's not tangible, okay? It's not something you grab. It's not candy, okay? But all right, Davis, if you don't mind, I think they sung for you, but I don't mind singing again. Happy birthday to you. Happy birthday to you. Happy birthday, dear Davis. Happy birthday to you. Yay. All right. Davis, how old are you now? 13. The big 1-3. You have changed from preteen to teen officially today. And I got to celebrate that, so we will. Anyway. Sorry? Oh my goodness. I can wait for that. I will not rush that. Oh my goodness. It's so weird. Anyway, before I break down, start thinking about my age. How do I deal with this right here? How do I combine these two together? Nick?
I think I got this wrong, but just subtract them or add them?
Okay, so how would you subtract them?
I probably do this wrong, but I put 8.0.
Okay, 8.0 minus 3.9, is that what you did? Well, let's see what we get here. All right, 7, 1, 1, 4. So you got 4.1? M?
Oh, you gotta put the M.
Oh, yeah, so 4.1 M. What else about it?
Wasn't it negative?
It's got to be negative. How many you got negative 4.1 M? Good, that's it. So listen, when you're actually subtracting two numbers, please listen up because this is a key. I still see it in 8th grade. If you put the smaller number up top and the bigger number down low, answer's wrong. Okay, it is wrong. Can never do that, ever. Don't ever do that. Unless you're a teacher and you need to show the students what never to do. Okay, so do you understand? Yeah, there you go. That's another example. But anyway, just make sure you always put the bigger minus the smaller. Okay, your homework was going to be blah, blah, blah to blah, blah, odd, blah, blah, blah. Now it's simply blah, 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 odd. 17 to 39 odd. Page 237. All right. Happy birthday. Go ahead and get started here. I don't know why I keep forgetting that. Odd, yes, odd. 17 to 39 odd.